the debris becomes this mulching machine, this sandblasting machine, this thing that ablates the entire coastline, wiping it clean of all traces of civilization. So have a nice day. Thank you for your... Thank you.
Thank you, Dr. Tyson. I remind our radio audience you're listening to the Commonwealth Club, a noon session with Dr. Neil deGrasse Tyson, talking generally about his new book, Death by a Black Hole, but more generally about current issues in astrophysics and cosmology. We have some time for questions. As you might see, if you've been watching, I have a fistful of questions here, and we will obviously not get to all of them, but let me try to get to as many as we can. First question is, there's a lot of discussion today about whether it's economically and scientifically better to pursue manned space travel or unmanned space travel. Could you comment on that question?
Sure. If I wear my scientist hat, as a pure scientist, I say, send the robot. Okay? Robots don't need to come back. You barely need to feed them, all right? And you don't have to keep them toasty warm. So robots are very low maintenance compared with human beings. If your goal is scientific inquiry. However, there's a whole other dimension to exploration that transcends science. There's the adventure, there's the urge to explore. If you look at the history of the greatest explorers, none of them were scientists. The science that got done as a product of their efforts were basically piggybacked their missions. And some of those missions had other kinds of motives, some military, some hegemonistic, how's that word go? Hegemonistic, some economic. And so there are drivers far stronger than scientific inquiry that moves money from societies to discover things. And so I don't want to be my read of history tells me I should not go forward with the naivete that you can just stand in front of the Congress and say, do this because the science is what we need. The history of funding major projects is a consistent demonstration of the failure of that as the sole driver for doing these kinds of activities. Not only that, there's just the practical matter. The MAN program is embedded in multiple congressional districts across the country with representatives that vote NASA's budget. So it's much more complex than just whether or not you're going to get a scientific result back. And when you factor in that full dynamic, you do both, because the last I checked, no one has ever named a high school after a robot.
The general battle between religious discussion around creationism and notions of Darwinism and origins of the universe have occurred in the biological sciences. Are you finding that the physics and other cosmological studies are now starting to take up that debate?
It's being taken up a little bit. I have direct measure of that where I work. I work at the American Museum of Natural History. We have an entire exhibit on the Big Bang and the origin of the universe. And another part of the museum, there's like the Hall of Human Biology. But what happens is, if someone comes in saying, how come you don't mention God here? Where is, why not? And what I do is, I just send them over the Hall of Human Biology, where we have humans holding hands with chimpanzees. And then they never come back. Like, that was enough to completely derail the inquiry. So my read of concerns within the religious community, it is vastly more concerned about our near identical relationship with the chimpanzee than it is about whatever we say about the Big Bang. Mm-hmm. Now, I've been brought into some of that conversation just to help people understand what science is and what science is not. And so I think what's unfortunate about how that's turned is religion is becoming sort of the enemy of science, or science the enemy of religion. And that's only because religious forces are trying to put religious writings in the science classroom. Now, there's no tradition of the science professor knocking down the door of the Sunday school telling the preacher to put science in what goes on in the Sunday school class. There's no tradition of that. There are no scientists picketing outside of churches saying, you know, equal time for Darwin. That doesn't happen. It's not how this country was founded. So it's this needless debate going on out there when people need to know if your belief system derives from what's called inspired truths that do not come out of empirical investigation of the physical world, it has no place in the science classroom. That doesn't mean it has no place anywhere else. Put it in the religious philosophy class. Put it in the history of human thought class. But it just has no place in the science classroom. And it's not about the First Amendment. It's about what is science and what is not. And that's where I put it. Thank you. Oh, thank you.
During your talk, you used the term thought experiment several times. Could you expand on that phrase?
Oh, thought experiment is what you do if you don't have any money. Okay? If they declined your recent grant proposal, then you just do the thought experiment. The thought experiment is you're armed with enough sort of laws of physics, and you want to test them in some way. So you invent, in fact, thought experiments came into fashion in the time of Einstein, because Einstein was a theorist, and many of the famous Jewish physicists of the day were theorists, because they weren't given money to be experimentalists. Many of those Jewish physicists were in Germany, and the German culture, the German philosophy at the time, held that experimental science was the highest form of science you could do. And the theory was what laggards would be left with. That's the crumbs on the plate. So Jewish physicists of the day could not be experimentalists. So they were relegated to the backwaters of theory. And in fact, that is the birth of modern physics, the theoretical discoveries that came out of that. So Einstein, not having the benefits of a laboratory, would take an idea and see what the consequences of that idea would be by constructing a thought experiment. What would happen if I took a beam of light on a moving train? You would see this pattern if you're on the ground, but if you're on the train, it just goes straight up and down. So how can one person see this angle, but you see this going straight up and down? And out of this unfolds the theory of relativity. And so a thought experiment is basically how to get closer to nature on a budget.
We read about the new particle accelerator coming online in Geneva at the end of this year, and then there was an article today about a possible even more high-energy accelerator being built in China. What will be the contribution of these facilities to the types of problems you're thinking about?
Anytime you build a facility that probes nature in regimes never before seen, you're going to make a discovery of something. That's just the history of the field. And that's why we can say pretty much with confidence that if all you have is a tabletop, laboratory tabletop, you're not going to discover a new law of physics there. You're probably not, because you're not at the limits of the regime. We've been there already. We're done with that. Take me someplace I haven't been before, and then show me a vista never before dreamt. And so these particle accelerators are creating energy environments that we've never seen before. And under certain levels of energy, matter behaves differently. New kinds of particles show up. Maybe they were predicted, maybe they were not. One of the biggest challenges in modern day astrophysics is what is dark matter? There's some stuff out there in the universe that has gravity, but we don't know what it is. It doesn't interact with our matter, and it's 5 times of it than it is of us out there in the universe. So we're the small fraction of stuff we don't know what it is. I got this whole chapter, there's a whole place in here. You want to learn about the depth of our ignorance, well, you go in here, you'll find it. Here, the book, that is, for the radio crowd, who doesn't see my gesticulations towards the book.
Yeah.
And so, sorry everyone out there in radio land. So if I walk to the left, I have to like do footsteps, right? Like they used to do. So, where was I again before I interrupted myself?
Somebody on the right, please.
That's their big chance. A particle accelerator, so you're at the limit.